right, guys, welcome back. This is going to be the 2.3 instructional video, and this one will be broken up into two different parts. In this first one, we'll kind of intro the concepts, work through a couple problems, and then the next video we'll do just two or three, I think it's three more problems, kind of practicing what we've been doing. So I would encourage you, follow me step by step in this one. Maybe you take a little more freedom in the next video, or if you feel really good right now, go ahead and, as we work through problems, try them on your own. So let's dive in. What is 2.3? Well, 2.3 is we're just going to keep building on solving equations. As DJ Khaled, you saw above, would say, another one. We're just going to keep solving equations. The only difference is they're going to get a little more complex. Now, what is the new wrinkle we're adding into things? Well, the idea is make sure as you solve equations, you always combine like terms if you can. Right now, we've kind of seen equations in their simplest form. We have a number and a variable equals something else, and we get rid of what's attached to the variable. And then we moved in 2.2 to, okay, we have a coefficient and a variable, and then another constant. And so we move the constant and then again, split up the coefficient and the variable. And again, that was fine. But now we're going to move into more complex problems. And what we always want to do is we want to make sure we combine like terms. Okay, so let's look at an example together. 2c plus c plus 12 equals 78. And again, if you feel like you can solve this on your own, be my guest. Go ahead and solve it. So I'm looking at this problem, and what I see here is I have a couple variables. I'm not used to seeing this. I haven't really seen multiple variables before. Usually I just have one variable on one side of the equation. We move all the stuff that's not the variable, and we arrive at our answer. But here we have multiple. Now the good news is they are the same variable. What I observe here is I have two c's, and then I have another c being added to those two c's, and then we're adding a 12. It's kind of like saying I have two apples, another apple, and 12 oranges. And you might go, well, that's dumb. Why would you say it like that? Why wouldn't you just say 3 apples and 12 oranges? I agree. And that's the logic we're going to use here. We have 2c plus c. And those are like terms. So our first step is going to be, oh, well, we can write this in a similar or a simpler fashion. If I have two c's and I'm adding a c to it, well, then I have 3 c's. Plus 12. Now, again, we've talked about this in previous videos. The 3c and the 12 aren't going to combine, right? If I have multiple apples, if I have 2 apples and another apple, well, I can combine and just say I have 3 apples, but I can't combine apples and oranges, so to speak. So the 3c and the 12, you can't simplify anymore. And again, we haven't really touched the right side yet, so he's just kind of along for the ride. And what's cool is once you combine the like terms, you know how to solve this. This is what we did in 2.2. We have a coefficient and a variable. We have a constant. How do we isolate the variable? That's what we did in 2.2. So we're just dealing, when we look at the equation in black, really, it's kind of a 2.2 equation in disguise in a little more complicated form. In any case, let's finish solving this one out. I'm going to subtract 12. Remember, we always want to move that constant that we don't want. We want to get rid of that constant on the same side. We want to get rid of the constant that's on the same side as the variable, because we want the variable by itself. So how am I going to get rid of that constant? Well, I have a plus 12 if I introduce a minus 12 into that left side. The plus 12 and the minus 12 being like terms and inverse operations, and the same value will cancel. But what I do to one side, I must do to the other, so I subtract 12 from the right side as well. And I get 3c equals 66. 3c equals 66. Well, what I'm going to do now is I have this 3 being multiplied by the c. I don't want that 3. I want to cancel it out. So I divide by 3. Since the 3 is multiplied by the c, we do the inverse operation of division. And when we divide by the exact same thing, because anything divided by itself is just 1, 1 times anything is just itself. So I have C on the left, but I must do the same to the right side. So 66 divided by 3 will give me 22. And now I have a value for C. Okay, we have a value for C. I'm not going to box it up yet. I'm just going to go ahead and check it. Again, we always want to check our work. And the beauty of algebra is if we plug our answer back into the original equation, I can check my work for myself. If the two sides of the equation are equal, well, then that is the true value for C. That makes the equation true because both sides are equal. If it's not, well, then our value is incorrect. It will not make the equation true. So what I'm going to do is I'm going to plug in 22 for C, and it's going to be a little more complex now that I have multiple C's, but nothing we can't handle. And this should all equal 78 if indeed our correct value for C, our solution, is 22. Well, 2 times 22 is 44. 44 plus 22 is 66. 66 plus 12 is 78, which is the exact same thing as the right side. And so we conclude our answer of 22 is indeed a solution. So the big idea here, not a lot new. It's just we had a little more complex equation at the beginning, but we simplified it down by combining like terms. Okay, let's look at another example. 4x plus 16 plus 2x equals 46. 4x plus 16 plus 2x equals 46. Okay, I would encourage you, if you found the last one fairly simple, try this one on your own and check your work with mine. If you're still a little bit confused about what's going on here, that's okay. Just check or follow along with me. Try and work ahead, pause the video at various points. And if you're really stuck, email me letting me know what questions you have. Well, again, I think maybe this analogy, I don't know if fruit analogies help you. They seem to help me. When I'm looking at this left side here, I go, oh my gosh, I got a couple x's. I want to get this down to one x. I want to isolate x, and that's got how I'm going to figure out x is. But before I can get to isolating x, well, I know I want the x on the left side. I have to deal with the multiple x's. Well, not to worry. They are like terms. Again, the situation I'm imagining here is if the constant is represented by oranges and anything with an x is representing apples, this reads I have 4 apples plus 16 oranges plus 2 apples. Well, the simpler way to say that would be I have 6 apples. In other words, always start by combining your like terms. Hey, these are identical terms. They are both x's. And so what I will do is I will combine them to be 6x. And notice I don't touch the 16. I don't combine the x's and the 16 when I'm adding and subtracting. Okay, I don't do that. I think in a previous video I gave again a more in-depth analogy of why when we are combining like terms, when we add and subtract, you combine coefficients via like terms, but when you would divide a side or multiply a side by something, that would apply to everything. Again, I think I go a little more in depth in the 2.2 video there. So if you have questions about that, let me know. But we only want to combine our like terms here. And so we combine the 4x and the 6x, but do not combine it with the 16 because they're not like terms. So now what we want to do is we want to get the variable by itself. We learned in 2.2 that we will subtract the constant. When we do that on the left side, of course, it cancels, inverse operations. And And on the right side, 46 minus 16 is 30. Now I'm going to divide the left side by 6. Do the same to the right. And when I do this, I end up with x equals 5. X equals 5. Again, I divided by 6 because the 6 is being multiplied by the x. We want to do the opposite to undo that multiplication, so to speak. So we divide by 6. What we do to one side, we must do to the other to keep our equation balanced. And when I do that, I get x equals 5. Again, plug that back in and check your work. We can do that really quick here. Little extra time, but a good thing to do to make sure we have the correct answer. I'd advise doing this on your tests. 4 times 5 is 20, plus 16, plus 2 times 5 is 10. 20 plus 16 plus 10 will give you 46. Those line up, so the equation is true, and we know our answer, our solution is correct. So the big moral of the story here is we want to make sure that when we can, to simplify more complex multi-step equations, we always want to make sure we watch out for like terms. If we can combine like terms, always start by doing that. And when we do that, what we see is we just end up with a 2.2 equation, which we've already seen how to solve. So that'll conclude part 1 for the 2.3 video. Again, let me know if you have any questions. We'll go into some more examples, some more complex examples in the part 2 video. And as always, let me know how I can help.